Okay, so guys, so the next three sessions, okay, probably I guess for the last one, okay, the last one probably you're supposed to have an online class, so I don't think you'll have a issue with that. So the other two sessions, okay, the video will be uploaded. So you are going to watch the video, okay, and by the end of the video, I've allotted assignments. Okay, it is not like the same assignment for the entire class. I've divided your whole class into batches. Okay, and each batch and each group, okay, according to how you are grouped, okay, you are going to do your assignments. So before you go to your class, see that you watch the video, okay, the class session, the online video session, and then you can go to the class, you can start doing your assignments, okay. So for the other students, probably this is video one, okay. So this video one, the assignment is allotted only to a very few group students, okay, not everybody. So the rest of the students will get the assignment from video 2 and video 3 and as such. Okay. So the others, what you are supposed to do is you are still supposed to sit and work regarding the models that are being taught. Okay. Okay. So probably in the previous classes, we've seen a very elaborate introduction related to your machine learning, right? So now we're going to start with the models. Okay, so what does this model do and all that? Okay, so the first question for you here is what is meant by model? Okay, so as you can see, the common thing which you've been talking about is this, right? Data set splitting, training data, testing data, your accuracy. When I tell machine learning, the purpose, when I ask a student, what is the purpose of using machine learning or why have you adapted machine learning? The common answer I get is accuracy, precision. The common one is accuracy. Okay. So we know so much about data, training data, testing data, and all that. Many miss the part here, the models. Okay, so we are going to start with your module one here. You're going to learn different models. Okay, so as I've asked you, so what is meant by this model? Okay, and I tell what is model. What do you think would be the suitable answer for it? Okay, so I'll just give you a. This is not a memorizing phrase or something. Okay, this is just for you to remember. Okay, so what is a model? So these models are considered as output of algorithms. Okay, when they are applied to a data set. So if I'm just going to put it out, models are the output of algorithms. Okay, so what are you going to do with this? So what are you going to do with the output of algorithms? You are going to apply this. Okay, you are going to apply the same to a data set, right? Okay, so when I tell, I can also ask you what is being learned from data. Okay, you are trying to solve a task, right? You have a model. Okay, you have a data, your data set or your data, and then you have a task, right? So what are you trying to do here? You try to acquire the data, right? And you're trying to accomplish your task by using your model, right? So these models form the central concepts in machine learning. So what do they help you to do? They help you to learn from the data. Okay, these models will help you to learn from the data. Okay, and what are you going to do? You are going to learn the data, you are going to understand the data, and then you are going to solve the given task. Okay, so this model will first help you to learn your data. Okay, this will help you to learn the data, and then you are going to solve the task. Okay, so this is your common concept here. Okay, so coming to, okay, so this is a small diagram of what happens. Okay, you have your machine learning model. Okay, the data set is given, you've decided your optimization metrics. Okay, your constraints are also given. Okay, and you're trying to automate all this. Okay, this is what you basically try to do in a model. So what we are going to learn here is we are going to learn different types of models. Okay, we are going to learn different types of models so that you learn to apply them in new data sets, and you also know how to apply models for different behaviors and also to predict new behaviors. Okay. Okay, so okay, so I'll tell you there are three models. Okay, the first one is we are going to like there's a vast range of machine learning algorithms. Okay, that can be applied to a given problem. So there are three models that we are going to learn now. The first one is the geometry of the instance space, or you can just call it as geometric model. Okay, and the next one is by using a logical expression. And the third one is using probability to classify the instance space. Okay, I'll repeat it for you again. The first one is by using the geometry of the instance space. The second one is by using a logical expression. And the third one is by using probability to classify the instance space. So for this session, we're going to learn about geometric model. Okay, so when I tell geometric model, it clearly, I'll tell you there are certain keywords, and that is how we are going to learn this. Okay, so this geometric model, what is a geometric model? Okay, so it is termed as set of all possible instances, that is instance space. Okay, a geometric model is defined as set of all possible instances, that is instance space. Okay, so now what is this instance space? Okay, so for example, like you have a set of all possibilities or describable instances, like whether they are present in a data set or not. For example, like if all features are numerical, then we can use each feature as a coordinate, like probably in a Cartesian coordinate system. Okay, that is how your instance space works. So an example for your geometric model would be I think you've heard of the nearest neighbor approach, which is employed. It can also be employed in classification and regression problems. So this geometric modeling in machine learning is a class of models that describe and process data using geometrical ideas and methods. Okay, I'll repeat this for you. A geometric model in machine learning, okay, is a class of models that will help you to describe and process data using geometrical ideas and methods. So what is this geometric model in machine learning? What is this going to result in? This will help you to describe, and process the data. Okay. So now you know what is a geometric model, right? It works with instance space. And then coming to the next part, this will construct directly, okay, into lines, planes, and distance. Okay. And what does this lines, planes, and distance help you to do? All these helps you to have a easy visualization. Okay, that is why this is directly constructed into lines, planes, and distance. Okay, and coming to the last point about geometric modeling. Okay, the features which we use in models can be described into 2 dimensions and 3 dimensions as well. Probably if you worked in any of the models, you would know. Probably if your model is helping you to go for a output with 2 dimensions and 3 dimensions, that is x, y, or x, y, and z, you should know that you are using a geometric model. Okay, so this is all about your geometric model. Okay, so now coming to the types. Okay, when I tell types, there are 2 types of models in geometric models. The first one is linear based, and the second one is distance based. like sticking to its name, linear-based models works with lines or planes, okay? And your distance-based models starts to work with distance-based models, okay? So the geometric concepts like lanes or planes, what are they used here? They are used to segment, okay? Segment or classify the instance space. These are called linear models, okay? So what will your linear-based model be used for? This is used for either segmenting or classifying, okay? Okay, so how does your linear based, your output, your model look like? This is how it looks like. Okay, so so as you look into it, you can realize these linear models. Okay, the first point about a linear model is they are relatively simple. Okay, they're relatively simple to understand, and like sticking to the diagram here in this case, the function here is represented as a linear combination of its input. Okay, so how is it represented as your linear equation? Like when if your f of x, for example, if it represents a straight line, your straight line, okay? So what is your equation? Your equation here is f of x is equal to mx plus c. This is one of your basics, right? You would have learned this in your schooling. So where your c will represent your intercept and your m represents the slope, right? So another thing about your linear model is they are stable, okay? They are simple, they are stable, and they also have low variance and high bias. So these are not just points to probably, like take it down, for your exam purpose, but when you make note of what are the, features or what does a particular model do, probably your task is to work with a data set, okay, where, the data set is very unstable, okay, you are supposed to go stabilize the data set, and also it has a low variance or a high bias issue and all that. You should know where or which model you are supposed to implement so that you can get a better accuracy. Okay, so that is the reason why we are segregating each model and we're learning them with their own features. Okay, and the next one here is we have another diagram. Okay, so this one has, all these terms, maximum, margin, positive, hyperplane, and all that, right? So what happens here is these geometric, linear model concepts are applied to high dimensional spaces, okay? High dimensional spaces as in, when I tell high dimensional spaces, if you're going to work with high dimensional spaces, that is when that is when it is usually prefixed with hyper, okay? For instance, I can tell a decision boundary in an unspecified number of dimensions is called a hyperplane, right? So when I tell I'm working with high dimensional spaces, the phrase is automatically prefixed with a term called hyper. You bring in positive hyperplane, a margin hyperplane, okay, a negative hyperplane, okay, that is how it works. And this is all about your linear model. And coming to your distance-based model, okay. So your distance-based model, okay, so what does this do? Just like a linear model, as it sticks to a term and works with lines and planes, this model, they are based on the geometry of data related to distance, okay. And as the name implies, your distance-based models will work on a concept of distance. Okay, so some of the examples that are given here are commonly used. Where do you use it? Euclidean, okay, Minkowski, your Manhattan, and all that. Okay. So what happens here? Your distance is applied through the concept of neighbors and xn plus. Okay. Your good example is nearest neighbor. Okay. So the neighbors are points in proximity with respect to the distance measure when expressed through the xn plus. Okay. So your main concept, okay, which is applied through your distance based model. Are neighbors and neighbors and xn plus. Okay. So what are these xn plus and what are these neighbors? Okay. So like I've told you, these neighbors are considered as the points of proximity. Okay. Points of proximity. Okay. So what are they going to help you with? They are going to help you with trying to find the distance measure. Okay. Okay. And the next one is xn plus. Okay. So what are these xn plus? These exemplars are like they're either centroids that find the center of mass according to a chosen distance metric, or they're called as medoids. Okay, I'll probably write down those terms for you. The first one is they're either considered as centroids, or medoids. So what are these centroids? They help to find the center of a mass. Okay. And what are these medoids? This will help you to find the most centrally located data point. Okay. Okay, so this is all about your distance-based model. Okay, so what it be looking to in the distance-based model, it is applied to the concepts of neighbors and exemplars, where your neighbors pertain to, so what is your neighbor? These are points in proximity with respect to the distance measure. Okay, and what are these exemplars? They are either centroids. Okay, so your keyword here is either. Okay, it is either a centroid or it is either a centroid or a medoid. Okay, so how will you identify it when you tell a centroid? It helps you to identify the center of a mass. And what will a medoid do? This medoid will try to identify or locate the most centrally located data point. And so your examples, okay? So your examples for your distance-based models are your nearest neighbor, okay? You've already worked with them, so I can tell you can relate with it, right? Your nearest neighbor, your k-means clustering, okay? All these are some of the examples for your distance-based model. Okay, so I hope you have understood. Okay, we started with a type of models, right? We started with type of models. We looked into what is model, right? What is model? So, and we have analyzed that there are three different models, right? Geometric models, logical expression, and probability. And now we have started with geometric model, where we've seen two different models, linear and distance. What is the linear based model? Is what does it pertain to? where does it work with when applied, and also about your distance-based model. Okay, so this is it for your first session. So your next session will be about logical expression. Okay, so I'll be uploading the video, after which, okay, in your GCR, I'll allot the group of students who are going to work on distance and linear based models. Okay, your register numbers will be given. So you can start doing your assignment, and the next class, okay, probably the first class, that is on 3rd, the class you're going to have on 3rd, you can spend the time, okay, you can spend the time, do the assignment. The other students can as well sit and try to analyze, okay, try to find a data set and try to implement these models in it. Okay, and in the next class, which you come, probably I think you'll have your next class on 4th or 5th. Okay, sorry, you're going to have your first class on 4th, right? And then probably I think you'll have your next class on 5th. So on 5th, you can bring your assignment. You should have completed your assignments. Right? You can either, probably I'll open a forum for you in your GCR, okay, or you'll be submitting a whole writer, okay, with the screenshots of the work that you have done to the faculty. Okay, so see that you sit in the class and complete your assignments.